Hello, good evening to you all.
Good
Good
evening,
evening,
sir.
sir.
Good evening, sir.
Yes,
Good evening, sir.
good evening. So, you're welcome to another FBA H40 class. Today, will be my last contact with you. From next week, another lecturer will take over. You guys have the teaching schedule, so you should know the lecturer that will be coming next week. So you quickly make the arrangement so that the lecturer will be punctual. So today we'll be discussing estimation and also hypothesis testing. So we have discussed sampling and sampling distribution. So this is actually the end goal of any sampling activity. Because the whole essence of sampling is to estimate the value of the unknown population parameter. If the population parameters are known, there's no need for sampling. So if you are aware and you are sure of the quality of the product that is being imported, then there's no need as a regulator, there's no need for you to start calling for sample for test because you are already sure of the quality. So the quality there, whatever parameter you are measuring, whatever regulatory standard that must be met will be your parameter in that case. So if as a medical doctor you are sure that a particular candidate has or a particular patient has malaria parasite in him or her, then there's no need for you to have recommended that candidate or that patient for a malaria blood test. So it is because it is unknown, okay? The parameter is unknown, and that is why you have always recommended to select some. So after collecting the sample, you make your observation, and then you make inference about the population. So at the point of estimation, you are likely to so I'll start all over again because we missed out a part in the recording. So I was saying that you're welcome to another FBA 840 class. That today's class will be my last contact with you, and that today we will be discussing hypothesis testing and estimation. So far, we have discussed in detail sampling and sampling distribution. And I was trying to recall that the essence of sampling is for us to estimate the unknown population parameter. That if the unknown population parameters are known, then there wouldn't be any need for you to take sample in the first place because every information about the population is known. So, and I gave the example of the regulator. You represent the SON, Standard Organization of Nigeria, and your job is to certify the quality of any product before it can be sold to the consumer. So you want to verify the fitness of the product for consumption. So if you are sure with certainty that the quality of the product that a manufacturer is producing or that an importer is bringing in the quality is known for sure, then there's no need for you to take sample. All you needed to do is just to give a pass for the products to be distributed to the consumer. However, it is because you wanted to be sure at all time, and that is why you call for sample from time to time to be sure that the quality of the product in the market meets the minimum requirement specification. So also the medical doctor, is not sure whether the patient has the malaria parasite or not, and that is why he or she will recommend the patient for a blood test. So if the medical doctor is sure, then there wouldn't be any need, for a confirmatory blood test because he's sure. Well, because he or she is not sure, and that is why the confirmatory test is always recommended. So the whole essence, of the sample is to estimate, of sampling is to estimate and also make inference about the population. So we're talking about the inference about the population. It's about testing the hypotheses that have been made about the population. That is confirming the truthfulness of claims that have been made about the product that is being certified, product that is being, being introduced to the market. So some claims have been made about the product, and then you, as a regulator, will need to confirm the authenticity of those claims. And that is what hypothesis testing is all about. You want to confirm the truthfulness of statements that have been made. Okay, so that is what hypothesis is about. So I will start with estimation, because I discussed estimation earlier. So we'll see how we implement, and also see how we can make use of the standard normal table and the T table in our estimation. So you guys have the slide. So I'll continue with the same slide that I shared last week. So I will advise that we go through to slide slide 16 of the FBA 840 lecture slides, partial, that I shared for 20th of January 2024. So this document supersedes the one that I earlier shared that contains only the sampling and sampling distribution. So in addition to that, I've included estimation and hypothesis, and we used this during the Saturday's class. So our estimation, while I was giving the explanation of basic terms that we'll be using in the course, I made mention of estimation. And I remember then that I told us that estimation is a procedure, the procedure of estimating the value of the unknown population parameter. I also remember that I told us that our estimation can be of two types. Our estimation can lead to a single value. So in that case, we call it point estimation. And our estimation can also lead us to an interval, a range of values, where we will specify the maximum possible, the minimum possible, with a given probability of accuracy. So in that wise, we call the estimation procedure as interval estimation. So what we have on the screen depicts a summary of that. So we have our estimation being classified as either point or interval. And I also explained to her what our estimators are, the formula that she used. So those formulas too can either lead us to a single value. So in that way, we call them point estimators. Otherwise, if they are used to set interval so that you will have the maximum possible, the minimum possible with some level of some margin of errors, then you have it as interval estimator or interval estimators, if you have to consider all of them. So our estimation is summarized here as a point or interval. So let's assume that you are interested in estimating the time that it will take for you to move from the island to FBA school. We don't put into consideration the new realities in Lagos Road. You know, it is possible for you to make a statement and say, from the islands, specifically, let's say from VI, but from VI after 2 o'clock, it will take roughly 2 hours to get to Yaba from VI. 2 hours to get to Yaba from VI. You could also make a statement as from 2 o'clock, getting to Yaba will take between 1 hour 30 minutes and 3 hours. Those are two different ways of estimating the time. So the first one is being definite, is giving a single value as the duration, of time from VI to FBA campus at Yaba, 2 hours. While the second statement is saying it can be as early as 1.5 hours, and it can be as late as 3 hours. So the first one is point estimate, while the second is interval estimate. So when you give a range of values, it's interval. When you give a definite value, it's it is point. So in the estimation, one will have to consider the details of the population you are working with. There are some population that the researcher has access to all available data, including the variance of the population. So which means you can compute the variance of the population and you can compute the mean or other relevant parameter about the population. So there are cases when the population variance is known about the population, and there are cases where the population variance is unknown. These two scenarios have implication on how the estimation will be done. So when the population variance is known, usually we assume that whatever estimation we'll be working with, as long as the data is reliable, we normally assume normality for it. When the population variance is unknown, that variance will have to be estimated from data. So in that case, it is the T distribution that will be used in the estimation. So this I will explain as we move on. But knowing the population or not knowing the population variance and not knowing the population variance has implication in the estimation as a whole. Now let's have a look at the flow chart that is being displayed. So you can see there's a case where the population variance is known, and there's also a case where the population variance is unknown. When the population variance is known, to construct a confidence interval, look at what we have at the left. We see that the confidence interval is being estimated as x bar plus or minus z alpha over 2 times sigma over root n. On the other hand, when the population variance is unknown, you can see it, that population variance will have to be estimated from the sample data. Hence, the confidence interval will be estimated using x bar plus or minus. Rather than using z alpha over 2, we will be using t alpha over 2. T alpha over 2, in fact, with n minus 1 degrees of freedom. That I will explain to us what we mean by degrees of freedom. Although we have been using it, majority of us might know what it means, but a few of us, I don't know. I think this will be an opportunity for you to know. But anyway, so when the population variance is known, this will be the formula to use. When the population variance is unknown, that is the formula to use. Irrespective of whether you apply in real life or you do it theoretically, your system, your program, your software implements these two formulas for you to get confidence interval if you are estimating the mean. But what you have here is the confidence interval for the mean. So specifically, the formula is clearly written here. X bar is the mean of the sample. We all know how to compute the mean. So the mean will be summation x all over n. Z alpha over 2. There are critical values that are obtained from the Z table, standard normal table. Now, why do you have to use the standard normal table? We use it because the population variance is known. If you have information about the population variance, you use the standard normal table. Okay? And then the sigma, of course, is the population variance. The square root of n, we all know what our n is, sample size. So sigma over root n is called the standard error. Okay? Standard error, sigma over root n is called the standard error. So when you multiply the standard error with z alpha over 2, you have what we call the margin of error. This is what we have on the screen, the margin of error. So you are saying if the margin of error is 2, for instance, and you are estimating the mean to be maybe 10, x bar to be 10. So which means that you will say that your mean falls between, you will subtract that margin of error from it, 8. You add the margin of error to it, it gives you 12. So you are saying that the mean can be as low as 8 and it can be as high as 12. So any value in between 8 and 12 should be a representative of your mean. Or you could even say that there's certain, maybe 95% confidence that your mean will fall between 8 and 12. Okay, so that is the margin of error. So the margin of error will enable you to get the lower limit and the upper limit. So that margin of error is computed as z alpha over 2 times sigma over root n if you are making use of standard normal table. Otherwise, margin of error will be T alpha over 2, the degrees of freedom, times S over root n. S here will stand for our standard deviation because you will have estimated it. Okay, so now let's look at a typical example here. We have a departmental store that want to determine at 95% level the average amount spent by all customers. So, which means it could be ShopRite, for instance, or you say Just Right. So you have been keeping records. So from the database, you want to know what is the average amount spent by your customer each time they visit your grocery store. So what will be the average? Okay, so you could just look at the total sales per customer, add them up, divide by number of customers that have patronized you, and that gives you the average. Okay, so if you follow that approach, you end up getting just one single value, and that's point estimate, whatever you arrive at the point estimate. But you could want to say, what is the lower limit and what is the upper limit? That is, what is the minimum expected amount that is spent on in our store? What is the maximum expected amount that a customer spent in our store? So in that scenario, you now have to construct confidence interval so that you will get the minimum expected amount to be spent and also get the maximum expected amount to be spent. So if the population variance is known, then you have to make use of Z. Otherwise, if it is not known, then you have to make use of T. Now, so going further, it says that the store took a sample of 100 customers. So database could be very, very large, and you might not have enough time to go through all the data, so you have decided to select. So the way you do your selection now matters. Do you want to select using simple random? Do you want to select using stratified? Do you want to select using systematic? Do you want to select using quota or whatever? So you determine how you're going to do your selection. And then once your sample has been taken, you go ahead and compute. So a sample of 100 is being taken. And then the average X bar is 82,000 naira. All right. So X bar is 82. So you want to construct confidence interval for that. Okay. So let's look at the formula for the confidence interval. Remember, once the population variance is known, you make use of Z alpha over 2. Otherwise, make use of C. So 82 is given. Z alpha over 2 is 1.96. I will show us how to get the 1.96 now. And then when you plug in the 1.96, the standard deviation is obtained as 20. And then remember our n. Our n is 100 sample. N equals to 1. So when you find the square root of 100, it's 10. Okay? Use 20 to divide 10, it gives you 2. 2 times 1.96 is 3.92. So if I may ask you, which of course I will do in my questions I will pose to you, what is the standard error in this case? The standard error, the margin of error. The margin of error in this case is 3.92. That's the margin of error. Okay, so it is that margin of error that you will add to 82 to give you the the maximum possible. It is the margin of error that you will subtract from 82 to give you the minimum possible. So that is why after adding the 3.92, you end up getting 85.92 as the maximum expected amount that will be spent in that store. While 82 minus 3.92, which is 78.08, will be the minimum expected amount that a customer will spend in that departmental store. So you can use this to, of course, to estimate the income at any given time. So if you have an idea of average amount that they will spend. So, and of course, that gives us the confidence interval. So here, the confidence interval is the minimum, that's the lower limit, 78.08, and the upper limit is 85.92. So how did we come about the 1.96? So now let's have a look at this table. So let's have a look at the table. So you guys have the textbook that I shared with you, remember? So at the beginning of the textbook, this table is there. This table is there. I want you to confirm that you have that table. So the table is a cumulative standard normal table. And the column of the table represents the Z. Remember, we want Z alpha over 2. The column is your Z. The table is actually a 2-page table. The first one is starting with minus 3. And then the second table ends with plus 3. Okay? So how do you make use of the table? How do you make use of the table? Your alpha will be given. Alpha is usually the error margin, the error that you want to permit in your calculation. We all know that there's no 100% efficiency in the calculation, in any calculation. So the error margin that is permissible is your alpha, although in hypothesis testing, we usually call it level of significance. So if the error margin is 5%, then our alpha will be 0.05. Remember, what we want is Z alpha over 2. Z alpha over 2 is what we want. Remember, in the formula, it is X bar plus or minus Z alpha over 2 times sigma over root n. So you want Z alpha over 2. So the alpha is given, the margin of error, 5%, 0.05. So if you divide it by 2, it gives you 0.025. 0.025. Now, if you say Z alpha over 2, you are looking for the value of Z that will produce 0.025. I think I will have to mute everyone. Sorry, I had to mute everyone so that we can have a smooth lecture. So, what you are looking for is the value of Z that will produce alpha over 2. That's what you are looking for. Which Z will give you alpha over 2? Remember what our alpha is, 0.05. If you divide it by 2, is 0.025. So you are looking for Z that will produce 0.025. So your job is to check the table where will you find 0.025 in the table? That's all. Which Z produce 0.025? Now, I want you to check 1.9 under 6. 1.9 under 6, please. 1.9 under 6. Can you see it? You will see 0.025 there. You can unmute it. If you can see it, I just want you to confirm that you can see it.
Yes, sir. Yes, sir.
Can you see 0.025?
Yes, sir.
Yes, sir.
So the value of Z that produced
Yes,
it is 1.96. Okay? So that's why if you check the solution, you will see that your Z alpha over 2 has been computed as 1.96. That's how it is used. Your job is just to search the body of the table and check for the value of Z that will produce your alpha over 2. That's all. So that's how it is checked. So if your alpha is 0.01 divided by 2, it will give you 0.005. Then you check the body of that table, which Z produce 0.005. And that's all. And that's what you will need as a Z alpha over 2. So you plug everything in here, and then you obtain your confidence interval. So that's how it is done using the Z table. And I've explained to us why we use the Z table when the population variance is known. There's a lot of theory behind it, which you don't need to bother yourself about. But just know that if you are computing confidence interval and the population variance is known, make use of your Z. Okay, so now let's look at the T table. Let's look at the T table. Now, if you check the screen, the title of the table is Selected Values from the T distribution table. All right. At the first column, you have degrees of freedom. Degrees of freedom. Then at the row, you have your alpha. Sometimes it is referred to as your error. Okay, so these are your alpha: 0.2, 0.1, 0.05, 0.025, 0.01, 0.005. Now, how do you make use of this table? You will always refer to the degrees of freedom, which is n-1, and then trace it to alpha. Now, let me explain the meaning of degrees of freedom. I have two values, say 1 and 4. And I want to find the mean of 1 and 4. You know, I will need to add, let's make it 1 and 5. You know, I will add 1 to 5 to give 6, right? And then I will divide by 2. That gives me 3. So 1 plus 5 over 2 will give me 3. But if I have information, if I know the mean, 3, how many of those values will I be able to manipulate to still produce a mean of 3? Immediately, remember the total has to be 6 for me to have a mean of 3. 2 values. So if I have information about one of them, 5, the total has to be 6. Automatically, I'll be able to get the second one. I know 6 minus 5 is 1, so the second one is 1. Assuming the first information, the first data is 3, the total has to be 6. Once I know about the first data, which is 3, automatically I know about the second one. So at that instance, I can only manipulate only one value. But once I manipulate one value, the second one is known. Now let's look at three values. I have three different values, 2, 4, 6, and I want to find their mean. The total of these three will be 12. The total will be 12. If I have information about one value, I won't be able to estimate, I won't be able to predict the third one. But if I have information about two of them, I will be able to get the third one. Assuming the first value is 8. So I'll take 8 from 12, I have 4. If the second value is 3, I'll take 3 from 4, then automatically the third one has to be 1. That's when the whole 3, if I find the mean of the 3, it will give me 4. It will give, yes. So that's 12 divided by 3 will give me 4, yes. So automatically, once I have information about 2, the third one will be known. Now, what does it mean? It means I have freedom to manipulate only one value in the first case out of 2. Once I have one information, the other is already known. Out of 3, I can only manipulate 2 values. The third one is automatically known. Your level of manipulation is called degrees of freedom. So in the first case, when I have n equals to 2, I can only manipulate 1. The degrees of freedom is n minus 1, 2 minus 1, 1. In the second case, I have 3 values, n equals to 3. How many of them can I manipulate at a time? It's 2. How did I get the 2? It's n minus 1, 3 minus 1, 2. That is the meaning of degrees of freedom. How many of the observation do you have freedom to manipulate? That is your degrees of freedom. So if you say it is n minus 1, it doesn't mean that it is statutorily n minus 1. That is how it is obtained. I have 5 values. If I manipulate 4 of them, automatically the 5th one will be known if I have information about the total. How did I get it to be n minus 1, 5 minus 1, 4. 4 will be my degrees of freedom. 4 values are the one that I can manipulate. So that's the meaning of degrees of freedom. So how do we make use of the table? Let us work together. So if I have a sample size of 10, okay, and my alpha over 2 is 0.05, what will be the t value? I have a sample size of 10, and my alpha over 2 is 0.05. What will be the t value? 10. 10 means I need to get the degrees of freedom. Is that not it? The degrees of freedom is n minus 1. That is 9. All right? So I will now trace 9 to under 0.05, and that is 1.833. So if I have 7 observations, what will be the degrees of freedom? 6. Okay? So if my alpha is 0.01, assuming my after dividing it by 2 is 0.01, what will be the t value? I will trace 6 to 0.01, and that will give me 3.365. So that is how the t values are obtained. You calculate the degrees of freedom, and then you trace the degrees of freedom to your T alpha or T alpha over 2. When do you make use of the T table? You make use of the T table when the variance is unknown. When do you use the Z table? You use the Z table when the variance is known. How do you make use of the Z? You make use of the Z by searching the body of the Z table and then looking for the Z that will produce your alpha over 2. In our case, our alpha over 2 is 0.025. So if you check, you will see that you can only get 0.025 under 1 on 1.9 under 6. Ignore the sign. Okay, ignore the sign. So that is how we have obtained our Z, and that is how you can always obtain your T table. So when you multiply your Z or your T with your sigma over root n, it gives you your margin of error. It is the margin of error that you will use to add and also subtract from your mean to get the lower limit and the upper limit. So that is how the confidence interval is obtained. Okay, so let's look at this particular example. We want to estimate the mean credit card debt of all customers in a country with 95% confidence level. So a sample of 70 households have been selected, and then we got a mean of 6,312, and then the standard deviation of 4,007. So if we are making use of the T table, T alpha over 2. So what is our degrees of freedom? Remember, our n is 70. Degrees of freedom was supposed to be 69. 69. Now let's check if our table has 69 in it. Ooh, this one does not have 69. Okay, this one has. So we're going to check 69 under 0.025. Can you see it? We got 1.995. 1.995. Please, you can always cross-check that. So that is our T alpha over 2. So that value will now be used to multiply our sigma over root n. What is our n? 70. Okay, so what is our sigma? 4007. So when you plug that together, you should end up with this. So which means that the debt, the credit card debt, should be between 8,357 and 10,267. So that is the average debt per household. That is how the confidence interval for mean is constructed. You can also construct confidence interval for proportion. You can always also construct confidence interval for all other parameters. So you can read up on that. Now we can move to hypothesis. So I can take your question on estimation before we discuss hypothesis, if you have any, please.
Hello, sir.
Yes, I'm listening.
Good evening. Thank you very much. You were telling us different times that we should use each of the tables, the Z table and the rest. Can you please repeat it, sir?
Okay. So I said the Z table is used when the population variance is known. The T table is used when the population variance is unknown. The question will state it that a population, okay, has certain parameters with population variance this, or population standard deviation, whatever. So you know that you have information about it. But if it is not known, that means you will have to collect information from that population and then estimate it. So if you have to estimate it, then you wouldn't make use of the Z again. You make use of the T table. Okay. So for the Z, you are only searching for the value of Z alpha over 2 in the body of the table. The Z that produce that value is what you are looking for. But for the continuous, for the T table, you need degrees of freedom. And I've explained to all the concept of degrees of freedom, although it is roughly calculated as n minus 1 in this case. So you need your degrees of freedom and then the alpha or alpha over 2. So you will trace your degrees of freedom to the alpha or alpha over 2. Whatever you have is the T table. Ebenezer.
Thank you, sir. Good evening, sir.
Evening,
Yes, sir. My network has been very bad, and the first example that you took us through, where we have a population of 100. How did we get 20, sir? When we put 20 over the square root of 100, how did we get the 20, sir?
I'm trying to put it on the screen so that everybody benefits from that.
Sir.
Oh, okay. The 20 is the population variance given. The population variance is that sigma. This sigma is given. The population variance. It will be part of the question. The population variance is we didn't estimate it. The only thing that we can put here is the square root of 100. Okay, that is n, and it's also given. Z alpha over 2 we obtain from the table. So when we multiply all of this, it gives us the margin of error. The margin of error here is 3.92. The mean is also stated, okay, 82. So when you subtract the margin of error from the mean, it gives you the lower limit. When you add the margin of error to the mean, it gives you the upper limit. So in this case, the sigma will be 0. So you can always see it from chapter 10 of the textbook. Is there?
Okay, sir. Thank you, sir.
Sekinat, you can ask a question, please.
Okay, thank you, sir. So yes, I'm still, there are some parts of the one I did not clear about the one Ebenezer asked now.
Okay.
You said that sample side, we're going to deduct 1 from and trace it on the table to get the value.
Degrees of freedom. Degrees of freedom.
Yes, but on my own table here, I think 100 will minus 1 from the 100, which is the sample size, to give us 99. So with this, I'm seeing 1.84, but you write 1.96.
Oh, okay. For the Z table,
yes,
you don't need degrees of freedom for Z table. You know, for Z table, once the population variance is known, you're not using the T table. It is the T that you need the degrees of freedom. But instead, if you check the Z table as I've displayed on the screen, what you are checking for here is Z alpha over 2. What is alpha over 2? Alpha is given 95%, so which means that there's an error margin of 5%. So if you divide it by 2, that will be 0.05. So you're looking for the Z that will give you 0.05. Your job is to search the whole table. Okay, where will you get 0.025? Now look at what I have on the screen. Can you see it? You can see 0.025 here. And the value corresponds to minus 1.9 under 6. Minus 1.9 under 6. So as I said, ignore the sign. So it is 1.96. That's how we obtain the 1.96. It is you have to search the body of the table and look for that alpha over 2. So the z that produced it is your is the z value you are looking for.
Okay.
That's
Thank you,
how
sir.
I obtain it. Yes. Okay, so you still have there are still hands up. So please ask your question, Taufik.
Yeah, thank you, sir. Good evening, sir.
Yes.
Good evening, sir.
Evening. So I'm listening.
Okay, sir. So my question is this: you said the estimate we have points and we have intervals, sir. But the two formula that we are solving, the two answers, the known and unknown, both of them are giving us intervals, sir. The known and unknown, both of them are giving us intervals.
Yes.
Okay.
Yeah, it is the confidence interval that we are constructing for the two cases. For the two cases, it says 95% confidence interval. That's what we are constructing. And then we are looking at the case where the population variance is known and unknown. If it is point, calculate the mean. You will have only one value, x bar. That's all. If it is point estimation, okay, what is the average amount that a customer spent in a particular grocery store? And you just can get all the and then divide by n, and then you have your value, just one value.
Business, you need to work.
Okay, sir. Okay, sir. Thank you very much, sir.
Do you know that all the people that worked here, I'm telling you, you take life, don't take like the defensive. All the people that have worked here with you,
please mute yourself.
So, do we still have any question? Please, you are free to ask your question, okay? Especially when I'm about to ask you a question. You know, I'm going to share a link with you either this night or tomorrow. And I'll give you 2 weeks to answer your question. That will be your continual assessment. Initial continual assessment.
He's saying you are false. You like people's review towards you.
Kingsley.
You're not supposed to say this. I'm telling you.
Okay, so now let's move to hypothesis testing. So I'm very sure that the concept is not new to us, especially those of us that did the project at the undergraduate level. At the chapter 4 level, when you are about analyzing your data, many of us end up testing hypotheses. So the concept of hypothesis might not be new to majority of us. So as far as FBA 840 is concerned, what do we mean by hypothesis, and what are the different forms that you can have? Someone has made a claim, and to you are not sure, you wanted to confirm the veracity of that claim. In that instance, the claim represents an hypothesis that needed to be verified. So whenever an individual had made a statement that needed to be confirmed or otherwise, that statement can be regarded as a hypothesis. Hypothesis in statistics is just a way by which you confirm the truthfulness of various claims using facts and figures. So as far as we are concerned, we define the hypothesis as a guess or a conjecture about the value of the unknown population parameter. I have a product to sell, and I'm looking at the possibility of selling that product to you. The product is targeted at those within the age of 25 and 32. And someone had advised me that our MBA students are quite young, that their average age is 28. Remember, my product is targeted at 25 and 32. So there has been a claim that the average age is 28. But I wanted to be sure before introducing the product. I wanted to be sure that the average age is 28. So to me, whoever has advised me that the average age is 28, I just conjectured about the population. That person has just made a guess about the MBA students. The population here is the MBA students, MBA year 2. So I needed to now test to confirm or otherwise the average age of the MBA students. So he had made a claim that the average age is 28. So I can decide to claim against 28 and then look into the direction of, the way I'm looking at their faces, I think they are older. So I can look into the direction of greater than 28. I can also look into the direction of, I think they are younger, less than 28. That's another way of looking at it. And sometimes I can just be indifferent and say, I think they are not 28. So there are 3 different scenarios there. The first scenario, I'm looking at the upper value of 28. The second scenario, I'm looking at the lower value of 28. The second scenario, I'm neither looking at the top or looking at, I'm just saying it is not just 28. That means it could be higher or it could be less. So as far as this course is concerned, we refer to statements that needed to be confirmed, statements that needed to be tested for its truthfulness as hypothesis. So we define hypothesis as a guess or a conjecture about the value of the unknown population parameter. So why are you testing the quality of products before certifying them for consumption? You are simply testing hypothesis. You wanted to confirm the truthfulness of the claim of the manufacturer. You wanted to confirm the truthfulness of the claim of the importer. You wanted to confirm the truthfulness of the claim of whoever had brought the quality, the product for you to certify. The whole process is still hypothesis. They are testing. You just wanted to confirm, confirmatory analysis. So it's actually testing hypothesis, but testing that value against regulatory standard, or you can even test whatever you have against the statement that the person had made. So we define our hypothesis as a conjecture or a guess about the value of the unknown population parameter. There are 2 types of hypothesis. There is the null hypothesis and there is alternative hypothesis. The null hypothesis is a hypothesis of primary interest. That hypothesis that you wanted to reject or accept, that statement that you want to test for its truthfulness. That is our null hypothesis. The null hypothesis is the hypothesis of primary interest. It is the hypothesis that is always subject to test. It is the hypothesis that is either accepted or rejected. So that initial claim that someone had made about a population is the hypothesis of primary interest. It is the null hypothesis, N-U-L-L. However, the alternative hypothesis is the hypothesis that gives the direction for further tests when the null hypothesis is rejected. Look at the case of my average age of MBA students. Someone had said the average age is 28. Then I made a counter statement and said, looking at their faces, I think they are more than 28. So that is the alternative. I can look at their face and say, I think they are younger. They are less than 28. That is the alternative. Or I could have been different and say, it is not just 28. That's also an alternative. It gives me the direction to look for in searching for the truth. What is the true age? If after collecting information, I had rejected that statement of 28. So the next step will be what is actually the age. So the alternative will give me the direction to go in search of the truth, in search of the true age. So if I had rejected 28, then the question now is it 29? Is it 30? Could it be 40? Or they are very old, they are 30, they are 55. So alternative hypothesis is a hypothesis that gives direction for further tests when the null hypothesis is rejected. Then the sidedness of a test. We could have one-sided test, two-sided test. Still on our MBA student age, one alternative says greater than. The other says less than. And then the third one says not equal to. Now look at the greater than. The greater than, it's actually giving direction, definite direction, values to the right of 28. The less than is also giving a definite direction, values to the left of 28. But the third one is not giving a definite direction. It's neither to the left nor to the right.
Ogujimi Alaba, please mute.
That's the job of our co-host. That's why I meet some people co-host. You help me be unmuting or muting these people when they start making noise. So, the sadness of a test is the direction given by the alternative hypothesis when the null hypothesis is rejected. The direction, that is the sidedness. So we could have one-sided test or two-sided test. When you have the alternative saying greater than or less than, that is a one-sided test. But if you have the alternative saying not equal to, that is a two-sided test. So the sidedness of a test is being determined by the alternative hypothesis. The alternative says less than, it's a one-sided test. If it says greater than, it's still a one-sided test. But if it says not equal to, then that test is a two-sided test.
So please, can you define it again, please?
Yes. The sidedness of a test is the direction given by the alternative hypothesis. The direction given by the alternative hypothesis when the null hypothesis is rejected. That direction, if it is less than, one-sided test. The direction, if it is greater than, is still one-sided test. But if the alternative hypothesis says not equal to, then it is a two-sided test. Let me show you before I continue with the definition of other terms. Now look at the screen. Look at what we have here. The null is usually denoted by H naught. H naught. Okay? So the null will always be equal to. Okay, so H naught, our mean, equals to a value. Now let's look at the alternative. I can have my alternative as not equal to, you see there's a claim here that the average age is 25. The alternative says not equal to 25. This is a two-sided test. Or the alternative is saying less than 25. This is a one-sided test. Or alternative is saying greater than 25. This is also a one-sided test. It is when you have not equal to that the test will be a two-sided test. Otherwise, if it is less than or greater than, the test is a one-sided test. So let me continue with my definition of term. So we have looked at the null hypothesis. Remember, generally, we define hypothesis as a guess or a conjecture about the value of the unknown population parameter. Any statement that is subject to test, any statement that one need to check its truthfulness is an hypothesis. Then the hypothesis can be null or alternative. Null hypothesis is the hypothesis of primary interest. It is that hypothesis that you want to accept or reject. While alternative hypothesis is the hypothesis that gives you the direction to follow whenever the null is rejected. Now that direction is actually decidedness of the test. The direction could be one way or it could be two ways. When it is one way, either greater or less, this is a one-sided test. Otherwise, when you have it as not equal to, it is a two-sided test. Very simple. So you can see all these concepts are very simple and easy to understand. Test statistic. Test statistic. You see those formulas that you use in carrying out your hypothesis testing. Those formulas are actually called test statistic. So, what I will define them as a test statistic is a function of sample values. Function of sample values whose magnitude determines the acceptance or rejection of the null hypothesis. A test statistic is a function of sample values whose magnitude determines the acceptance or rejection of the null hypothesis, which simply means I have a formula somewhere, I plug in my sample values, whatever I get. If it is very big, it might be that my hypothesis will be accepted or rejected. If it is very small, it could be my hypothesis will be accepted or rejected. The magnitude, whatever you get, how big or how small it is, determines whether your hypothesis will be accepted or rejected. So that formula that you use on your data for you to take decision as to whether you should accept or reject is your test statistic. Now, while you are taking decision as to rejecting or accepting your hypothesis, you can commit two errors. You are liable to two types of error in hypothesis testing. You can reject an hypothesis that you ought to have accepted. That's an error. You can also accept an hypothesis that you ought to have rejected. That's also an error. Any other decision that you take outside these two, they are true and correct decision. So type 1 error is committed when a true hypothesis is rejected. Type 1 error is committed when a true hypothesis is rejected. Type 2 error, on the other hand, is committed when a false hypothesis is accepted. Type 2 error is committed when a false hypothesis is accepted. Then we also have level of significance.
Sir, please. Sir,
yes, ma'am.
Sorry, please. Can you explain the type 1 error again, please?
Yes.
Thank you, sir.
So I'll take it from the beginning that while taking decision, you are liable to two types of error. You either reject what you ought to accept, or you accept what you ought to reject. Those are the two types of error you can commit. Any other decision that you take outside these two, they are correct and true decision. Type 1 error. Type 1 error is committed when a true hypothesis is rejected. You are rejecting something that is good. You take it as being bad. You are committing type 1 error. But when you accept what is bad, something is bad, and you take it as being correct, that is type 2 error. Type 2 error is committed when a false hypothesis is accepted. Type 1 error is committed when a true hypothesis is rejected. So the maximum probability of committing type 1 error is our level of significance. That is that alpha that we have been talking about all along. The maximum probability of committing type 1 error is our level of significance, alpha. I'll take it over again. We started by hypothesis. There are guess, conjecture about the value of the unknown population parameter. There are always statements that you needed to check for their truthfulness. And our hypothesis can be classified as either null or alternative. Null is the one that you want to reject or accept. Alternative is the one that guides you as to further search once that null has been rejected. The direction that the alternative gives you is the sidedness of the test. So it could be one-sided, it could be two-sided. When you have less than in the alternative or greater than in the alternative, you have one-sided. But when you have not equal to in the alternative, you have two-sided. That formula that you use to determine whether you should reject or accept your hypothesis is called the test statistic. So we said it's a function of sample values whose magnitude determines the acceptance or rejection of the null hypothesis. And then we said that there are two types of error that you can commit when testing a hypothesis. You can commit type 1 error, can commit type 2 error. Type 1 error is committed when a true hypothesis is rejected. Type 2 error is committed when a false hypothesis is accepted. And then the maximum probability of committing type 1 error is the level of significance. It is that alpha that we normally write. The alpha that we have been writing all along, Z alpha over 2, T alpha over 2, that is the level of significance. That is the probability that you will reject what you ought to have accepted. So when testing hypothesis, there are some steps that you need to be taking. So the steps include, number 1, you state your hypothesis, both the null and the alternative, alongside with the level of significance. Step 2, you state the decision rule. On what basis do you want to accept or reject your hypothesis? Step 3, you state the appropriate test statistic. Which formula will you use to compute and then determine whether you reject or accept your hypothesis? Once that formula has been stated, the next step, which is step 4, is for you to compute the value of the test statistic from sample values. You have taken your data from your sample from your population, plug them into those formula, and then you calculate. Okay. Step 5, you go to your table and then bring out the appropriate critical value. Those table value, those T value, those Z value, get them out from the table. And then step 6 is for you to compare them, whether you need to reject or accept. And then step 7, which is the final one, you should conclude appropriately. So if you are accepting, what does it mean? If you are rejecting, what does it mean? That is a summary of how hypothesis testing can be conducted. So other lecturers will continue from where I stopped. I have just laid a foundation.
Sir, please, can you take the steps again, please, sir?
Okay. I said there are 7 of them, 7 steps that you need when testing hypothesis testing. The first one is that you state the null and the alternative hypothesis alongside level of significance. Step 2, you will then state the decision rule. On what basis are you rejecting or accepting the hypothesis? Step 3, you state the appropriate test statistic, that formula that you will use, that formula that determines whether you should reject or accept your hypothesis. Step 4, you now compute the formula based on your sample value. Remember, you have taken sample from your population. Plug them into those functions, you get a value. Step 5, you take your critical value, go to your table, the Z table or your T table, collect those Z or T value. Step 6, compare the T and the table value and what you have computed, and then you take a decision. Step 7, what is the implication of your decision? You conclude. If you are rejecting, what is the implication? If you are accepting, what is the implication? Those are the steps in the hypothesis test. So I've laid a foundation on which other lecturer will build upon, and then the course will continue. So I want to take your reaction before we close the class. I'm supposed to have 2 classes with you. I end up taking 3. So, but it's okay. At least it's for the better.
Sir, please, can you share all the materials you have used, please, sir?
Can I?
Can you share materials with us?
Sir. The very first day I met you, I shared about 4 materials. I shared a textbook with you. I shared a slide. I shared, in fact, 2 slides. And I've also shared some videos that contain question and answer. So I hope the class governor has shared.
Sir, we don't have this slide.
Not yet.
Who is your class governor?
I've never seen anyone.
Who is your class governor? There are 3 of them that I know. I know Chidima, I know George, and I also know
James.
Who is that other one? James, Abi?
Yes, sir.
Oh yeah, whom among them have not released to you? They are all here now. Tell me which one of them have not released to
you? James, I have not seen no.
Sir, all the slides have been shared. All the slides have been shared.
And the textbook too.
But sir, we don't have this pattern one.
They've been shared, sir.
3.
Please help us reshare on our individual stream platform, please, governors.
Okay, please,
Okay.
Governor, please share.
Okay, in case you
The
don't have
test
it, I will.
too. When I'm sharing the test, please, so make sure they all have it. No student will fail.
Yeah.
Uh-huh,
So the thing is just that some of them don't bother to open them.
And when they know that there's test, they will
So
open
if they
now.
have opened it, they would have known the contents.
All right. So,
yes.
So please,
So
guys,
it's
you
on their
guys
platform there.
All right. So, can I say bye bye to all of you? I see you when I see you.
Sir.
Yes.
Somebody is requesting if we can get the recording.
Yes, I will. Usually, I
Thank
send
you, sir. Thank you, sir.
Thank you very much, sir. Thank you, sir.
All right. So, bye bye.
Thank you for the recording.
Bye bye. Enjoy your evening, sir. Bye, everyone.